Where we stopped yesterday? The previous class. Screen is visible.
Yes, sir.
Anybody reply, please.
Yes, sir. Visible.
Visible. Okay. So in the previous class, we were discussed about the things, this derivation, the final derivation. If the P by Q, the outer ratio is not equal to inner ratio, then we'll get this complete formula. If the outer ratio, that is capital P by Q, equal to small p by q, then this term will become 0. 0 into this multiplication will be anything to 0. So on that condition, we are going to get R equal to P by Q. Yes, here. If the outer arm ratio is equal to the inner arm ratio, if it is not there, P by Q ratio is not equal to P by Q ratio, then we will get same formula. We have to use this one. We have to use the same formula. We have to use this one. All of you write this formula, this one, and this one. Both the formulas you write down in one paper. And now only I will tell you, people, please be ready with calculator, pen, papers. So today we are going to discuss the problems on Kelvin double bridge. Some numericals we are going to solve. After that, we'll go for the next. We'll go for the, that is Maxwell bridge. We will go that one. So all of you take the pen, paper, and write this formula and let me know. Over. Have I noted down the formula?
Yes, sir.
Okay. So we'll discuss one problem on Kelvin double bridge. The statement of the problem is Kelvin double bridge uses standard resistance. The standard resistance, that is 100 micro ohms. 100 micro ohms. 100 micro ohms. The inner ratio arms are 15 ohm and 30 ohm. Inner ratio arms are 15 ohm and 30 ohm. Outer ratio arms are 40 and 60 ohms. 40 and 60 ohm. If the resistance of the connecting leads from the standard to unknown resistance is 800. See here, S to R, that is called standard resistance to the unknown resistance is 800 micro ohm. Calculate the unknown resistance under this condition here. Under this condition, you have to calculate here. So I will explain first the problem, this problem I will explain. Then in the second problem, we can solve that one. See here, the standard resistance means which one? The standard resistance is nothing but, all of you know that one. That is 4 resistances are there. P, Q, R, S. P, Q, R, S. And for the inner side, that is called small p, small q, and that is R here. Yes, these are the points. This P and Q are the outer arm ratios. Yes, these two are the outer arm ratios. These two are the inner arm ratios. This R is the unknown resistance. S is the standard resistance. This R is in between from S to R. It is connected. That is a straight line is there. That one we are going to use. Okay. So the standard resistance, that is called what? Given data, what we have to write? Standard resistance means? Yes, that is called yes. Yes is given as 100 micro ohm here. That is 100 into 10 to the power of micro means how much? I'm asking to you people only. Micro means 10 to the power of. You people are direct second year students, are you peoples? Namrata. Micro
Yes,
means
sir.
10 to the power of. Micro means what? Milli means what? Kilo means
-6.
micro means
-6.
Seema. Seema, Kartika. Roll number 7, 9, 10. Give the answer.
Yes, sir.
Micro means what is the 10 to the power of?
-6.
-6. Very good. So that is 10 to the power of -6 ohm here. No, yes. Then inner arm ratios. Inner arm ratios means inside constant resistance say capital small p and q here. No, small p equal to 15 you take down, and capital P equal to, sorry, small q equal to 30 you take down. 30 you take down this one, and the outer arm ratios, that is called capital P equal to 40, and capital Q equal to 60 ohm. Okay. So next, if the resistance of the connecting lead from the standard to R, that is called small r, it is nothing but this R equal to 800 micro ohm is there. See here, 800 into 10 to the power of -6 here. 10 to the power of -6. See, first what you do, you check this one, P by Q equal to P by Q. Both the answer you are going to get equal or not. You check that one. This small P by Q equal to, what is the answer? Capital P by Q equal to, what is the answer? Both are equal answers you are going to get, or different answers you are going to get. You identify first. If they both are equal, then it will be that formula you have to substitute. If not, then we have to use the direct formula you have to use here. This is the given data. Here, what is the unknown resistance here now? I have written all value. Which one is missing here? Which resistance is missing?
Capital R.
Capital R we have to identify here. Capital R we have to identify here. So this is concept is clear. Given data. First I will ask that one. Then we will go for the next one. Is it clear, or you have any doubts? I'm asking you people
No,
only.
sir. No, sir.
Not clear. No means. No means not clear or no doubt.
No doubt, sir.
Okay, no doubt. So see here, I have typed this one, given data. We have written here, and we know the formula here. Now see here, the standard resistance S equal to 100 micro ohms. That is called micro. 100 micro is nothing but 0.0001. You can write like this. Yes or no?
Yes, sir.
Okay,
Yes.
0.001 we have written. Inner arm ratios or inner ratio arms is nothing but P equal to this one 15 ohm, Q equal to 30 ohm, and outer arm ratios are 40 ohm, P and Q equal to 60 ohm, R equal to 800 micro ohm, that is called 0.0008. We have used here. We know the formula, that is this formula only directly we use that one. If both are equal, we will get 0. Otherwise, we will get the R value direct. Okay. R equal to P by Q into S. R equal to P by Q into S plus Q into R. We know the value of Q equal to 30 into R is nothing but 0.008 divided by P plus Q plus R into P by Q minus P by Q. All of you have the calculator? Will you tell the answer?
Yes, sir.
Yes, sir.
See here, P is given, Q is given. All the values you know with this one. Only directly you have to substitute in the formula directly. Just substitute and calculate that one. And tell the answer to me. Just substitute the value. Here you substitute P equal to 40 here now, divided by 60 into S is nothing but 0.001. That is plus, this is 30 into 0.008 divided by 15 plus 30 plus 0.008, open bracket, that is 40 by 60 minus 15 by 30. 15 by 30. Substitute, do this one, and whatever the answer will get you, just substitute here. Tell the answer, any one of you. Anyone got the answer? How many of you are doing calculation? Raise your hand. Two persons. Only 2 persons are doing the calculations. Other people's, what you people are doing? Viraj, City Viraj, we're doing the calculation. Viraj City,
Yes, sir.
कर रहे क्या नहीं calculation? संतोष 33.
Yes, sir. कर रहे हैं.
सत्यम खाड़े 24.
Yes, sir.
कर रहे क्या calculation?
Yes, sir.
कॅमेरा ऑन करून दाखव मला. कॅमेरा ऑन करा, तुमचे नोटबुक मला दाखवा. काळे सत्यम कर रहे क्या नहीं, बोलो सच में. सत्यम काळे, आई एम आस्किंग टू यू ओनली. रिप्लाई तो दे दो.
1.55.
1.55. What is the unit?
Micro ohm.
Micro ohm. Let me check that one. Let other people's to do the calculation. I will disclose the answer. Any other persons? We are told 1 point. How much it is?
5.
1.55. Okay. Okay. Very good. Very good. This is the correct answer only. Other people's, you have to do the calculation as early as possible. So already everything is ready here. I have everything given data. I have given written here, and even no need to convert into the point also. I have everything is ready. Even just substituting the value here now. See here, this p equal to 40. 40 I have substituted. Q equal to Q. So 60, that is 60 I have substituted. S equal to 0.001 I have substituted. Plus Q equal to 30 into R is 0.008. We have substituted here. P plus Q plus R. This is 15, 30, 0.008. 15 plus 30 plus 0.008. Open bracket ko open liye. 40 divided by 60 minus 15 divided by 30 here. Next step, what we have to do? We have to calculate this part separately here now. Next, this part separately here. So 40 by 60, that is called 2 by 3 minus 1 by 2, that is called 0.1667 is the answer. And this complete derivation 30 into 0.8 divided by this all the things, that is 45.0008, will get that 0.000533. That is, and plus that 6.6667 divided by 10 to the power of minus 5, we will get the answer here now. So this is minus 5, this is minus 5, is nothing but 6.667 into 8 point. That is called, by simplifying this equation by using the calculator, directly by using the calculator, we can say that one, that is 1.55 into 10 to the power of minus 6. Minus 6 is nothing but how much? That is micro or milli or kilo or mega?
Micro.
Micro here, no? So the answer is 1.555 micro here. Any doubts here? If you
No,
have
sir.
any doubts, you ask me now only, because the next problem I'm going to use same type of problem. I'm not going to tell anything. I will display the problem only. You have to tell the answer for me. You have to tell the answer for me. Some people, they have joined now. Sonali Chavan. You take the screenshot or you note down the formula. Same type of problem I am going to give here now. If you have any doubts here, you can ask me. Now only you ask all the peoples. The same type I am going to give. All of you ready to do the problem? Solution for the problem?
Yes, sir.
Yes?
Yes, sir.
Okay. Note down this problem then. See here. A Kelvin double bridge is balanced with the following constants, that is called outer ratio arms are 100 and 1000 ohms. Inner ratio arms are 99.92 and 1000.6 ohms. Link resistance is 0.1 ohm. Standard resistance is 3.77 milliohms. Find the unknown resistance here. Find the unknown resistance. So you take this problem, all of you. I will give the time for you people. That is 2 minutes time I will give. That is 3:32 is there. Up to 3:35, I will give the time to you people to solve this problem. To solve this problem. And tell the answer to me. Will you solve now? All of you will solve the problem. Will you solve or not? If anybody has a doubt, sir नहीं होते मेरे को ऐसा कोई है क्या? If anybody is there, सत्यम काले है क्या? हाँ सर कर रहे बोले कैमरा ऑन करो बोल दिया तो साइलेंट हो गए. Harshavardhan Mohite 28. Who want to tell the parameters? What is the given data? Who want to tell? Raise your hand. What projecta is ready? Next. Any other persons? I'm asking only what is the given data. Pooja and projecta both are ready. Other peoples. Namrata. Okay. Vinayak Gore. Very good. बहुत सारे लोग ready हो गए यार. Okay. We'll give the chance to the new persons. Namrata. Namrata, tell me what is the given data? Unmute करें. Seema, roll number 7. No need to worry about that one. Just tell me what is the given data. You can speak out. Unmute करने का सर ये 100 है ना, ये है, Q है, R है क्या, P है, कैपिटल है क्या, स्मॉल है, उतना ही बोलने का है. Just you have to tell that one. Given data, in the given data. Who want to tell? Directly you unmute and you speak out. Nobody is ready. Pooja?
Yes, sir.
Yes, what are the given data?
P is equal to 100 ohm.
Which P, that is capital or small?
Capital.
Okay.
Capital Q is equal to 1000 ohm.
Yes.
Small p is equal to 99.92 ohm.
Very good.
Small q is equal to 1000.6 ohm.
Okay.
Small r is equal to 0.1 ohm.
Very good. Huh.
Capital S is equal to 3.77 million milli ohm.
Okay. Milli means 10 to the power of minus
-3.
Okay. Okay. So which one you have to identify?
Capital R.
Capital R. Very good. Very good. Very good, Pooja. Okay. So the given data, capital P equal to 100, capital Q equal to 1000, the small p equal to 99.92, and the small q equal to 1000.6, and the small r, that is called link resistance, which is connected between standard resistance and unknown resistance, that is called 0.1, and the standard resistance S equal to 3.77 into 10 to the power of minus 3 here. Now you have to identify the value of r, you have to identify here. So this is the given data here. This is the given data. 3.77 into 10 to the power of minus 3 is nothing but 0.00377 here. Okay, we already know the formula. This is the formula, we know that one. Just substitute these values already. We have written values in this one and tell the answer here. Anyone have calculated? Calculation is over. Any one person? केला का calculation कोई तो? If anyone has done the calculation, then tell me the answer. Nothing to worry, it may be correct or wrong. No need to worry, just substitute here. In the place of P, you substitute 100. In the place of Q, you substitute 1000. In the place of S, you substitute 0.00377 plus Q equal to this 99, sorry, this one 1000.6 into the R is nothing but this 0.1 divided by 99.92 plus 1000.6 plus 0.1 into this one 100 divided by 1000 and minus that is 99.92 divided by 1000.6 here. Okay. I have already substituted this value. I am waiting for your response of the last answer. Any one of you can tell the answer who has already finished the experience. Yes, what is the answer?
3.784 into 10 raised to minus 4.
Into 10 to the power of
Minus 4.
minus 5. Okay, we'll check that one. Only one person is saying the answer. Other people, what you people are doing, I don't know. Again and again, only one person is saying the answer. All of you have to involve in the numerical methods. The colleges are going to start in the offline. The offline, this type of problems may come. So we have to practice this one. Okay. So we'll check that one. Next point here. This one you separate calculate. This one you calculate. This one you calculate. So after calculating this part, that is 0.00037 plus that is this one 0.099. This one, all the points we have to consider because it is measurement of Kelvin double bridge is suitable for high voltage, medium voltage, or low voltage. Yes. The Kelvin double bridge is used to measure low resistances, high resistances, or medium resistances. Which one?
Medium resistance.
Medium resistance. Yes. Any other answers? Kelvin double bridge is used for the measurement of high resistances, medium resistances, or low resistances. Which one? Any one option. This question is asked in the ISC also, I think. Not this question.
Low resistance.
Low resistance. Here is there competition, but okay. One person is saying low resistance, another one is saying medium resistance. Which one is the correct answer? The third person you can tell.
Low resistance.
Low resistance.
Low resistance is the correct answer. Low resistance is nothing but from 1 ohm to the, suppose some milliohms, micro ohms, so micro ohms or nano ohms also. We can consider that one here, low ohm. So for that reason only, here the resistances they are going to give in milliohms, micro ohms there we are getting here now. So calculation में ऐसा 0.09 आया तो 0.0909 4 digits consider करते हैं. That is not good for this method. Kelvin double bridge के लिए आप ऐसा use नहीं करने के. Calculator में कितना digits है, all digits you have to use here now. All digits you have to use. All digits go next. This all digits you have to multiply that one. So that answer we are going to get, that is called 0.000389 here. So 1, 2, 3 we have considered is nothing but that is called 0.389 milliohms also we can write, or 389 microohms also we can write here. 389 microohms also we can write. 1, 2, 3, 4, 5, 6. 6 digits. The point is I am going to shift here now. That is right side shift is nothing but minus. Left side we have shift is nothing but plus. We can write that one. Yes, that is 389 microohms or 0.389 milliohms or 3.87 10 to the power of minus 4 also correct answer. How many of you got this answer? Raise your hand. 3.8 10 to the power of minus 4 or 38.9, that into 10 to the power of minus 5. That is also correct answer. Only one person she got the answer. Okay, so it completes the Kelvin double bridge, but it has some limitations also here now. So we are going to discuss those limitations. We are going to discuss limitations of Kelvin double bridge here now. The sensitive galvanometer we are going to use here for detecting the balance condition. So that is the very sensitive element we are going to use here now. That is not actually if for high resistance, that is it is going to non-sensitive. For that reason the errors may occur that one. So sensitive galvanometer is used. Then the high measurement current is required for obtaining the good sensitivity. The measurement of current is required very high for obtaining the good sensitivity here. So these are the two limitations, and some points you have to note here that for obtaining the appropriate result, it is very essential that the ratio of their arms is equal here. The arms of that ratio will be equal. That is essential part. The unequal arm ratio causes the error in the result. It is going to cause the error in the result. Also, the value of R should be kept minimum for obtaining the exact result. So whatever the link resistance is there between the standard resistance to unknown resistance, we have to keep that one as minimum as possible. That one, then only that will negligible error will not create in that one. So next we'll go for the AC bridges. That is the bridge uses for measuring the value of unknown resistance is for the DC we have used. Okay, for the combination of resistance, inductance, capacitance we are going to use, that is called AC bridges we are going to discuss here. If we are going to measure resistance, inductance, resistance and capacitance, that is the measuring method, that is called AC bridges. We can use that one here. The bridge uses for measuring the value of unknown resistance, unknown inductance, unknown capacitance is known as AC bridges. By seeing this definition, anyone can you tell me the DC bridge definition? The bridge which is going to measure the unknown resistance is called as DC bridge. But for the AC bridges, we are going to measure unknown resistance, inductance, capacitance here now. So the AC bridges are very convenient and give accurate result of the measurement. These are also convenient and they are going to give the accuracy is the main advantage of the bridge circuit we are going to use here. In an AC bridge, each of the four arms, whatever in the bridge form they have considered, that is 4 arm, is an impedance here in the AC circuits. Previously क्या था? अभी this was the bridge circuit. Yes, in this bridge circuit we were used R1, R2, R3 use किया था ना? Yes sir, no?
Yes, sir.
R1, R2, R3 बोल के use किया था. Okay, so that is resistance 1, 2, 3, 4 we were used. But here what we are going to consider, each 4 arm is impedance here now is nothing but instead of R1 what we will do, that is called Z1, Z2, Z3, Z4 we are going to use here. Z1, Z2, Z3, Z4 we are going to use here. That is each of 4 arms, each of the 4 arms, that is Z1, Z2, Z3, Z4 we are going to consider. Z indicates that is impedance here. So the battery and the galvanometer of the Whitson bridge are replaced respectively by an AC source here. Instead of battery, we are going to use the AC source. Instead of galvanometer, we are using a sensitive detector. We are going to use to small alternating potential differences here. Now, for the small alternating difference potential, we are going to use a sensitive detector. We are going to use here. So the usefulness of the AC bridge circuit is not restricted here. We can useful that one to the measurement of unknown impedances, associated parameters like inductance, capacitance, storage factor, dissipation factor we are going to use here. All the factors we are going to measure. We can measure the impedance, capacitance, even resistance also we can measure by using this bridge here now. We'll get the formula for both resistance, inductance, both resistance and capacitance here. So the word it came that is called impedance. So anyone can you tell me what do you mean by impedance? Anyone? So just basic, actually it should not, I should not have to tell these all the things directly. I have to go for the Maxwell bridge. But some people they came from the ENTC and some people they came from the computer science in your class. For them it is going to help. बाद में उधर directly हमने Maxwell bridge में impedance बोल के use किए, उनको confuse नहीं होने का. For that reason I am taking these all the things. Yes. Anyone can you tell me impedance means what? Okay, leave that one. सबको resistance का definition मालूम है? Definition I am not asking exact definition. What is the principle or what it is going to, what is the function of resistance?
Oppose the flow of current.
Oppose the flow of current. In the DC bridge, we are going to use resistance. But in the AC, we are using in the place of resistances are replaced by impedances here. Now, what is the function of impedance then?
Oppose the flow of
It
current.
is also, the impedance is also produce the opposition to the flow of current only here. When voltage is applied, it is opposition to the flow of current. But the main difference of impedance and resistance is the impedance is the combination of resistance and reactance, which is nothing but there are two types of reactances are there. That is XL and XC. I don't know how many of you heard this one. In the first year you have heard this one. This X R plus JX, the complex form of impedance is this one here. Z equal to R plus JX. R is nothing but resistance. J indicates that is complex term and X is nothing but reactance here. Now, this reactance is maybe XL, that is called inductive reactance. XC is there means that is called capacitive reactance. We are going to call XL is inductive reactance, XC is capacitive reactance. Again, the question will arise here now. XL equal to omega L. I don't know how many of you heard the name here now. XL equal to what? Omega L. Omega is nothing but what? Anyone can you tell me? Omega is the angular velocity, that is called 2 phi f is the formula for omega here. 2 phi f and L I will write as it is here. L. Is it clear? All of you who is absent for today class, they will not understand anything. I am telling frankly. XL equal to omega L. Omega is nothing but angular frequency, that is angular velocity, that is called the 2 phi f here now. So L is nothing but inductance as it is. We are going to consider XL equal to omega L. Omega is equal to 2 phi f and L we have kept as it is. And similarly, this is for inductive reactance. XL is the inductive reactance. For the capacitive reactance, what we are going to consider? XC equal to, what is the formula? XC equal to, can I write omega C?
Yes, sir.
No, here only will fail. XL equal to omega L is correct, but for the capacitance, XC equal to 1 by omega C we have to write down here. The term formula is XC equal to 1 by omega C is there. Again, the omega equal to 2 phi f, 2 phi f. So for your confusion को हटाने के लिए मैंने क्वेश्चन पूछा था, ऐसा लिखो क्या बोलते? Okay, 2 phi f into C here. XL equal to omega L, that is correct. XC equal to 1 by omega C you have to write down. That is the principle of the capacitive reactance here. Capacitive reactance. Okay. So in electrical engineering, this one is over, na? Okay. Impedances extends the concept of resistance to alternating current AC circuits here. It is extends the concept of resistance to the alternating current here now. Impedance possesses both magnitude and phase here now. It is going to have both magnitude and angle here now. In the form of that is angle, that is polar form we have written here now. Z at an angle of theta we can write, that is. Z is the magnitude, this is the angle here. That is phase here. Unlike resistance, which has only magnitude. Resistance has only magnitude, but it has angle also, phase also it is that here now. A circuit where current lags 90 degree in respect of applied voltage for the pure inductive circuit here. This one I will explain in details. Just a minute here. Where here I will start. Here I will start. I will write the voltage equation. I will write here. Voltage equation I will write here. Okay. See here. The circuit where current lags 90 degree for the inductive load. If the inductive load is there, here I will take the red only. This is 0 is there. One cycle. This one we are going to call as one cycle. We are going to call that is phi. That is 2 phi. 2 phi is nothing but how much it is? 2 phi equal to the degree. In a circle, what is the angle degree of circle?
360.
360 degree. So for 0 to 5 is nothing but 180 degree. From 5 to 2 5, that is called 180 degree. 180 plus 180, 360 degree. So that is one cycle it is going to complete. From 0 to 0 it came means one cycle we are going to call that. So for the inductive circuit, if the current lags the voltage by 90 degree here, for a circuit where current lags 90 degree, then respect of applied voltage in a pure inductive circuit here. Current lags means voltage se current piche hai. Yes, this is called voltage. I will call it one as voltage is there here. So for the inductive load, I will consider the blue here. No, either 0 hai, either 5 hai. So 90 degree kahan hai? This one 0 to 5, half consider karna hai na? Yes.
Yes.
180 here, 5 is nothing but 180. Here 0 to 90, 90 to 180 here. Now, so the middle of that one. So voltage 0 se chalu ho gaye, to after 90 degree, what will happen? The current will start to flow here. The current waveforms we are going to get here now. So the current lags the voltage for 90 degree we are going to call for pure inductive circuit. There will be no resistance and all the things. Only inductive rehna chahiye. That is for the inductive circuit here. Next, for the capacitive circuit, what will happen? The current leads here. No, leads means either 0 se chalu ho gaye. 0 se pehle chalu hone ka, that is called leads. Yes, 0 se pehle kaise? Iska either 0 hai, it is called minus 90 degree. इसका पहले कौन सा आता है? माइनस 90 डिग्री है ना? यस सर नो? इधर प्लस 90 है तो इस साइड में माइनस 90 है. उसका पहले चालू हो जाएगा. That is called the current leads the voltage by 90 degree. We are going to call that. Current leads the voltage by 90 degree. But if the pure resistive circuit is there, there is no inductance, there is no capacitance, only pure resistance is there. On that condition, there does not lag or lead here, no, which is in phase. In phase means both will start. The magnitude may be different, but starting point and the end point will be same here. That is called in phase. We are going to call this is voltage. This is current here. This is current here. These 3 points I have explained here. Now, if you have any doubts, you can ask now only. Any doubts? किसी को कुछ डाउट है?
No,
Yes.
sir.
No doubts. Okay. I'll go for the next. That is called. We know the formula for the inductive triangle. Directly I will go this one. This is impedance triangle. We are going to call that one. Okay. Impedance triangle. See. So for the previous slide only I have taken. Okay. See here. How we got this impedance answer here now? We know the formula of the triangle that is called here. See, all of you know this triangle. That one, I will consider this one as a resistance, this one as a reactance, and this one as Z here. Z. So we can write that one Z square equal to R square plus X square. Yes. The mathematics, I don't know how many of you studied here now. I don't know how many of you studied. Can I write like this?
Yes, sir.
Yes or no? I will tell you just a minute. Once again, I will draw in a simplified form. See here R is there, here X is there. Okay, so this is called R and this is called X here. The sum of this one, that is called Z, we are going to call. We are going to call Z here. So Z square equal to R square plus X square we are going to call. So if equal to Z square is there, I want to remove Z equal to here, means this will nothing but square root will come, square root of R square plus X square. A square equal to 3 plus 4. So A equal to square root of 3 plus 4 will write. Yes or no? Class चलो है. Is it correct? So Z square equal to R square plus X square. So Z equal to square root of R square plus X square. We can write here now. And for the same triangle, I don't know how many of you remember that adjacent, opposite and hypotenuse. All of you मालूम है सबको? मैथमेटिक्स में स्टडी किए क्या? Yes or no?
Yes, sir.
Adjacent, this is called opposite, this is called hypotenuse here now. What can anyone tell me the formula for tan theta? Here the theta is there. Just imagine that is tan theta equal to. Anyone, can you tell me the formula tan theta equal to? Yes. Adjacent divided by
Opposite.
adjacent divided by opposite we can write, that is called tan theta equal to adjacent divided by opposite here now. So the adjacent is R and the opposite is X, R by X, that is called theta. We are going to call tan theta. So theta equal to tan inverse of R by X we can write here. With these all the formulas you have to remember. Okay, in the complex form we can write Z equal to R plus JX here. Now J indicates a complex term. Here the real part, this is the reactive part, that is called net reactance, we can call this one here. So this is the simple brief introduction about the impedance here. Now we'll go for the Maxwell bridge directly, that is AC bridges we are going to use. So bridge used for the measurement of self inductance of the circuit, that is called Maxwell bridge we are going to consider here. So it is an advanced form of Whitson bridge. Whitson bridge same like a Whitson bridge only, but the resistances are replaced by the impedances here now. Impedances we are going to call. So the Maxwell bridge works on the principle of comparison here now. That is called the value of unknown impedance is determined by comparing it with the known value or standard value here. We have to compare with known value or standard value it is going to consider. There are two methods of Maxwell bridges are there. Anyone asked means you can tell that one. The Maxwell bridge is used for the measurement of self-inductance only, but two methods are there. One is Maxwell inductance bridge we are going to call. Another one is Maxwell's inductance capacitance bridge. In the bridge we are using inductance and capacitance both, but the unknown value is inductance only. The use is going to use it for the measurement of self-inductance only. The first one we will take that one, that is Maxwell inductance bridge here. Maxwell inductance bridge here. See here, is there any difference comparing with the Whitson bridge? Anyone, can you tell me? See here, if there is no L1 नहीं है उसमें Whitson bridge में, L2 नहीं है, बाकी other things are same only. R1 है, R2 है, R3 है, R4 है. Yes?
Yes, sir.
So all other things are same only, but there is no L1 and L2 here now. So for that reason, what we have to call this R1 and L1, that is called Z1, we are going to call this one. And this R2 and L2 plus L2 has a variable resistance with some resistance value, variable inductance, that is called Z2 we are going to consider. And R3, that is called Z3 we are going to call here. No, R3 is Z3 and R4 is nothing but that is called Z4 here. R4 is nothing but Z4 here. Okay, so this is the term we are going to call. So this one impedance we are going to measure here. So before that, so R1, R2, R2, R1, R3, R4 are the, that is non-inductive resistance value we have used here now. L1 is the pure inductive value. L2 is having, that is variable inductance with some resistive part here now. That is called, we are using here now. So before discussing the equations and all the things, I will tell the circuit diagrams here. So here the AC supply we have provided here. AC supply we are going to provide. The current will start to flow here. That is, I will start to flow. This current flowing through this one is, that is called I1. We have written here, that is called I1. Here, whatever the current will flow, that is called I2. So voltage drop across here, I will consider the I1 and I2. I will take the reference here. I will take I1 and I2. I will take the reference here. So voltage drop across the resistance, that is called pure resistance. There is no, that is, that one I will call it as VR1. I will call this one. So I1 R1. According to Ohm's law, what is the formula for voltage?
V is equal to IR.
V is equal to IR. So here the resistance is there, that is called R1. Which current is flowing? That is called I1. So the voltage drop across this R1 is nothing but R1 into I1 here now, which is in phase with the same current here now. So I have drawn here, that is called I1 R1. I1 R1, it is going to call that one here now. What is this one? This is a pure inductance. Yes, this is inductance only, na?
Yes, sir.
This pure inductance, then what will happen from here to here? It is 90 degree. It is going to lag here. The voltage drop across this one is leads here. No, voltage leads. See here, current and voltages are there. If current is lagging, we are going to call means voltage should be, current lag कर रहे बोल दे तो voltage क्या रहते? Lead में रहते ना. So here the current I have taken reference here. No, voltage drop across inductance L1, that is called E1, is in leading here. No, that is how much angle is there here? 90 degrees. 90 degrees there. Then similarly the R2 we are going to call here E2 R2. This is also pure resistance. So I2 R2 we are going to consider here now. That is I2 R2. It will comes under here only. And here it has some resistance, inductance here. No combination is there. For that reason, some angle it is going to change here on the dotted line with that is called I2 omega L2 we are going to use here. Omega L2 here. Next R3 and R4 pure resistances are there. So voltage drop across this one also is in phase. That is called E3 and E4 we have written here now. E3 and E4. So the net voltage, that one we are going to call, that is E. It has some angle that is called phi. We can consider that. This is the phasor diagram formation we are going to call this. This one is the phasor diagram formation. So for this circuit, in the tomorrow class, what we will do, we will write the equation for Z1 equal to what, Z2 equal to what, and Z3 equal to what. The formula we have to write Z2, Z3, Z4, and according to the Whitson bridge, what is the bridge balance circuit? R1 bridge balance circuit. Whitson bridge के हिसाब से क्या हुआ है? R1
R4.
R1 R4 equal to
R2 R3.
R2 R3 है. So the resistances are replaced by inductance, impedances. Then we can write this one as Z1 Z4 equal to Z2 Z3. Yes or no? Z1 Z4 equal to Z2 Z3. If you know the value of this one equation for the Z1, then you substitute here. Z2 का equation you substitute here. Z3 का substitute करो. Z4 का substitute करो. Later क्या करने का, real term and real imaginary term separate कर दो. We'll get the answer for that one. The self inductance here. So we'll discuss in the next class. This part we will discuss in the next class. I will stop here only, and these equations, derivations are there. We'll discuss that one in the tomorrow class here. समझ में आ रहा है कि नहीं? Understanding? कुछ भी रिप्लाई मत दो आप लोग. ठीक है, we'll stop here only and we'll continue in the next class.